Hi everyone. In this lesson, we're going to learn how to calculate credit score. We calculate individual credit score the same way we calculate the power on which we have to raise an exponent to get the odds of being a good borrower. As you know, every borrower can only fall into one dummy category of every original independent variable. Moreover, we estimate the coefficients of the PD model with variables whose value is 1 if the borrower falls into a category and 0 if they don't. Therefore, what we did is simply sum the dummy coefficients of the borrower categories. In the same way, to calculate the credit score of a borrower, we only have to sum the credit scores corresponding to the respective dummy categories. Let's see how it's done. We'll use the borrower with index 362514 again. First, we take 312 as our starting point. That's the score, corresponding to the intercept. Next, we see that the external grade of this observation is C. Thus, we add the corresponding score of 53, and we get a total of 365 points. Then we take a look at the home ownership status once again. The borrower's status is mortgage, so we add the score of 8 and get a sum of 373. Next, knowing the borrower lives in California, we add 5 and reach 378. We continue in the same way, summing up the relevant categories to get a final credit score of 608 points. Now let's calculate all scores from the test dataset. We'll use the inputs test with reference categories data frame, where we have the dummy variables for all test dataset observations. Calculating their credit score is no different. We already have the corresponding coefficients from the scorecard, so we are left with addition and multiplication. We can easily multiply the values by the coefficients, but first, we have to make sure they're ordered the same way. First, in the coefficients, there's an intercept. There's nothing to multiply the intercept by in the test data frame. Sure, we could multiply only the values of the variables by the variable coefficients and add the intercept. However, it would be much more convenient to go with one multiplication. So, let's copy the inputs test with reference categories data frame in a new data frame called inputs test with reference categories with intercept. Now let's add a column of ones and multiply it by the score that corresponds to the intercept. This way, we yield the intercept score for all observations. We can achieve that by applying the insert method to the data frame. We can see that the first argument, 0, specifies the index where we want to add a new column. So, it will become the first column in this case. The second argument, intercept, is the name of the column. What about the third argument? It specifies the values of that column. Since here we want ones everywhere, putting a 1 will suffice. Now we have the data frame with a column taking care of the intercept, but we still have to make sure that the columns are arranged in the same order as the variables in the scorecard data frame. How can we do that? One way to do that is to use the inputs test with reference categories with intercept data frame, but set the column order equal to that of the feature name column from in the scorecard data frame. Now we can store the scores in a new variable. Let scorecard scores equal the scores final column from the scorecard data frame. This variable contains the scores in the order of the variables from the scorecard data frame. It also matches the order of the variables from the test data frame. So we've got everything we need. A good practice is to make sure they have compatible dimensions. The shape of the test data frame is 93257 by 102, and the shape of the scorecard scores variable is 102, comma. The 102 dimension is compatible. However, the fact that there is no second dimension can be an issue. Functions, such as multiplication, require matching shapes and matching dimensions. Therefore, to make the scorecard scores compatible, we must use the reshape method. Writing scorecard scores.values.reshape and indicating the new shape 102 by 1 will do the trick. Great. Its shape is now 102 by 1. Now we can safely multiply the test data frame by the scores. We want to multiply each row from the test data by the column with scores and then sum the products. In fact, multiplying all rows of two matrices of data frames and summing the products is known as dot product in linear algebra. There is an out-of-box method called dot that can help us with that. So, let's find the dot product of test data and scorecard scores. Here it is. Just as we calculated, the score of the first observation is 608. Moreover, the Y-score column contains the scores for all observations from the test dataset. Great work! We have successfully calculated the credit scores of all people from test data. See you in the next lecture, and thanks for watching.